Section 3.2 Applications of Radian Measure. Arc length. The length S of the arc intercept on a circle of radius r by a central angle of measure theta radians is given by the product of the radius and the radian measure of the angle. So arc length is talking about the side here, the S. Okay, and then from last sessions, we talk about it when the radius is equal to the length of the arc. It considered theta will be equal to 1 radian. Okay, so we do have this formula S equal to R theta, where theta is in radians. I want you guys highlight this one. Okay, S talking about the length of the arc here. Theta, it has to be radians. If they given the degree, you have to convert it to the radians. Question 1. When the formula S equal to R theta is applied, the value of theta must be expressed in radian, not degree. We talked about it already, right? Okay, let's try on this example. A circle has a radius 18.20 centimeters. Find the length of the arc intercept by a central angle with measure 3 pi over 8 radian. Okay, so we have the formula S equal to R theta. We know the radius and then we know the theta. Can you guys plug it in and find it out what is your S? Use your calculator. You should get 21.44 centimeters. Okay, B. A circle has a radius 18.20 centimeters. Find the length of the arc intercept by a central angle with the measure 144 degree. So same idea. Okay, you do have the same formula. The only thing you guys need to pay attention is theta equal to 144 degree. What do you need to do first? You're going to convert 144 degree into radian. So you're going to multiply pi over 180. You should get 4 pi over 5. Once you're done, you could use the formula, find out the arc length. Plug it in. You should get 45.74 centimeters. Example 2. Latitude gives the measure of a central angle with vertex at Earth's center, whose initial size goes through the equator and whose terminal size goes through the given location. We know Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, and that of Los Angeles is 34 degrees north. The radius of the Earth is about 6,400 kilometers. Find the north-south distance between the two cities. Okay, so you could see we do have the 34 and 40 degree here. Let's try to find the difference between here. So we're going to use 40 minus 34 degree, which is going to be 6 degree here. And then we want to convert the degree into radian. Use your calculator. You should get pi over 30 radians. And then we want to find the distance between these two cities. Okay. So we're going to let this part equal to the S. So S equal to R theta. The radius, that will be 6,400 kilometers. Theta, we're going to be using pi over 30. You should get 670 kilometers. Example 3. A rope is being wound around a jump with radius 0.8725 feet. How much rope will be wound around the jump if the jump is rotated through an angle of 39.72 degrees? Okay, so look at this picture here. We do have a rope here, and then we have the radius, and it creates the central angle. That's a 39.72 degree. Okay, we're gonna use the S equal to R theta. Keep in mind, when you have the degree, you have to convert it to radian in order to use this formula. Okay, I try to put everything together. I have the radius here, and then the theta will be 39.72 degree, and then I convert it to the radian. Use your calculator. You should get this guy. Okay, example 4. Two gears are adjusted so that the smaller gear drives the large one. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? So I do have two gears. The small one, the radius will be 2.5 centimeters. And then the large one, that will be 4.8 centimeters. So I know that the smaller one, they're going to rotate 225 degrees. So let's calculate about the S for the smaller one. First, we want to convert 225 degrees into radian. Okay. Now, we're going to find out the arc length for the small gear. So we're going to use S equal to R theta. Okay, the S here will represent the smaller one. And then we're going to plug it in. R will be 2.5. Theta will be 5 pi over 4. Which is 12.5 pi over 4. Let me try to get out of the decimal here. So I'm going to times 2 here, times 2 here. Okay. Now, I find it out the arc length for the smaller one is 25 pi over 8. Okay, when it rotates like 225 degrees. How about the larger gear? This arc length for the smaller gear will be equivalent to the arc length for the larger gear here. Okay, so we're gonna do the same thing. So we're gonna plug in 25 pi over 8 has the arc of the larger one. And then we know the R, right? And then this time we want to find out the theta. So you're gonna divide it by 4.8 for both sides. You're gonna get this. And then we want to convert back to the degree. Since the degree of the smaller gear is gonna be degree. So let's convert it back to the degree. So I'm gonna multiply by 180 over pi. You should get 170 degrees. Okay, I want you guys to remember this formula. S equal to R theta. And theta, it has to be in radian. Okay, area of a center of a circle. We know how to find the arc length from the previous slide. Now I want to find out the area, the dimension of this sector. And a sector of a circle is the portion of the interior of a circle intersected by a central angle. Okay, you could think about like a piece of the pizza. Okay, this part, that's called area of the sector. Formula: area equal to 1/2 r squared data. And again, this data will be in radians. Okay, in the formula for the arc length, the value of the data must be in radian. So same idea for the area of a sector. Make sure you convert your angle from degree to the radian. Okay, try this example. A center private irrigation system provides water to a sector-shaped field with the measure shown in the figure. Find the area of the field. So we just want to find this area. They given the radius. Okay, you could imagine this is a big circle. And then 321 meter will be the radius. And then we do have the angle 15 degree. So first, convert the degree into radian. You should get pi over 12. And then we know the radius is equal to 321. Let's use this formula. Plug it in. Use your calculator. You should get 13,500 meters squared. State the unit. Okay, the arc length is just the unit by itself. When we're talking about the area, it has to be square unit. That's it.